All right, now that we've multiplied rational expressions with monomials, now we got to go and do multiplying with polynomial expressions. Now, remember your definitions. Polynomial means the sum of many monomials. So if we're going to be working now with polynomial expressions, they're going to be connected with addition and subtraction. And we've already discussed this. You cannot do division if you're connected by addition and subtraction. You can only do division when your terms are connected by multiplication. So how are we going to fix that? Oh, now it's to start coming together. We know we could take a polynomial expression and factor it, which means I will rewrite it as multiplication. So my song now gets added on a little bit of a phrase. It starts out the same. Multiplying fractions is no problem. Top times top, bottom times bottom. Before you start to multiply, factor first, then divide. So now that we're going to be doing true algebra, we're going to multiply rational expressions, fractions that are all algebraic. They have monomials, binomials, trinomials in them. You know you're not going to be able to divide first because you're going to see adding and subtracting symbols. So we're going to have to go through our rules of factoring, factor our polynomial expressions, rewrite them as multiplication, and then we can do our canceling, our dividing. And then what's left over, we'll multiply across. So the song is real simple. Multiplying fractions is no problem. Top times top, bottom times bottom. Before you start to multiply, factor first, then divide. So let's look at our rational expression in our notes. B squared minus 64 over 9b plus 72 times 8b over 8b squared minus 64b. Now, ladies and gentlemen, you do not want to multiply first. You don't want to take that binomial times that monomial and do distributing in the numerator. And you surely don't want to take the binomials in the denominator and do FOIL. Then you'll end up making two really large polynomials, and then you'll have to factor them, and that'll be 10 times worse. So we want to do our factoring first. Any term that is not connected by multiplication, we need to factor. So we're going to start with the numerator, b squared minus 64. I'm telling y'all, the big three rules of factoring are GCF, difference of perfect squares, and trinomials. So you're going to always proceed in that order. B squared minus 64. Do we have a GCF? No. Is it difference of perfect squares? Yes. So it would factor to be two binomials that are conjugates. It would be b plus 8 and b minus 8. Now that numerator is connected by multiplication. Let's go down to its denominator, 9b plus 72. All right, there's an addition sign. I need a factor. First rule of factoring is GCF, 9b plus 72. Do we have a factor in common? Sure do. We have a 9. So we're going to pull out the 9 and put one parentheses and tell what's left when we divide by 9. And we'll get b plus 8. So now that first fraction in factored form is b plus 8 times b minus 8 over 9b plus 8. All right, we go to the second fraction. Let's look at this numerator. It's 8b. That's a monomial. The definition of monomial means it's already connected by multiplication. That's why we don't factor monomials. So we'll leave that numerator 8b. The denominator, 8b squared minus 64b. Okay, I got a subtraction. I have to factor. Here's the boo-boo you all make. You see the b squared and you're automatically putting two parentheses. Sweeties, is that a trinomial? No, there's only two terms down there. Is that difference of perfect squares? I don't care that it has a different sign. I don't believe the number 8 is a perfect square, and I don't believe the letter b is a perfect square. So the problem is you guys jumped the gun. You don't think about the rules in the order I've been telling you to memorize them. The first rule you always look for is GCF. Does 8b squared and minus 64b have a term in common you could factor out? It sure does. You can divide both of those terms by the number 8 and the letter b. So we're going to pull out the 8b, and that's going to leave in one parentheses b minus 8. So your second fraction is going to be the 8b in the numerator, and in the denominator you have 8b times b minus 8. Now that your fractions Every term is written in factored form, which means it's connected by multiplication. Here we go. Now we're ready to cancel divide. We're going to look for something in the numerator, a term in the numerator, and a term in the denominator that's exactly alike that will cancel out. So if you look at the first numerator, you have a b plus 8 and you have a b minus 8. If you start looking in your denominators, in the first fraction in the denominator, there's a b plus 8. So that b plus 8 in the numerator and that b plus 8 in the denominator cross out. We're dividing the same binomial. We make a 1. If we look, still in the numerator is a b minus 8. Now directly across from it in the denominator is a b minus 8. Those are exact same binomials. Those will cross out and divide and make a 1. If you want to put the 1, you can, but you don't need to. I'm going to go to my second numerator. It's got an 8b. Well, right underneath it in the denominator, there's an 8b. So we're dividing the same binomial. That cancels out. Now, if you look closely, all the terms in the numerator canceled out. So the numerator is blank. What does it mean when you divide the same exact value? What is always your quotient? 1. So you need to put a 1 in the numerator. If you look very closely in the denominators, every term canceled out except for the number 9. So in the denominator, you have a 9. So the product of those two rational expressions happens to be the constant 1/9. That rocks. You took two fractions that were all algebraic, and when you multiplied them, you got out a real number 1/9. All right, let's go to the whiteboard and try another one.